Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from lesson 5-1 in the SavvasRealize Algebra 2 textbook. We are learning how to simplify nth roots. Change to black, there we go. So, when we're simplifying an expression, alright, you can see here, make it a little bigger for y'all. You can see here that we have a number and a letter being multiplied in here. Okay, so when we're simplifying these roots, this has to be multiplication here in the radicand. Okay, if this said 32 plus m to the 15th, that is a whole other ball game, y'all. Okay, it has to be multiplication or division works as well. Okay, so let's check this out. So 32. All right, I'm going to go ahead and do the prime factorization of that. I know that 32 is 8 times 4. 8 is 2 times 2 times 2. And 4 is 2 times 2. So 32 is the same thing as 2 to the 5th. Now on these problems, I find that it's easier just to write it in exponential form. I'm going to show that to you on some of these other ones, but the logic here, right, is kind of like a game of Go Fish. So you need 5 of a kind to remove something from a radical. So I have 5 2's here, so that 2 is going to come out. Like the root and the exponent cancel out. Now m to the 15th means that I have 15 m's sitting here. So I could take out an m 3 times. Alright, so that is actually the way that it evaluates. Now all of these, I'm kind of disappointed with these examples, all of these give you like perfectly divisible numbers, so you're always going to get some nice root. This method that I'm showing you here is really nice when you don't have these like perfectly divisible values. Okay, like you see, like 4 goes into both 20 and 8, or 12 and 24, and 3 goes into 3 and 9. Like if it wasn't divisible, like if this was an 8 and I'd have leftover b's, for example, this method is nice. But I'm going to show you the other method, which is converting these into exponential form. So here I'm just going to write this out with fractional exponents. Now recall that the index here, the number on the outside, turns into the denominator of the fraction when we have it in an exponential form. So this is going to turn into x to the 24ths, y to the 8/4. Okay, so because these are both under there and it's multiplication, we can distribute that 4th root. Now remember, these are fractions, and fractions follow a certain set of rules. Fractions can be simplified. Alright, so 24ths, 20 divided by 4 is 5. And 8/4 is 2. Alright, so sometimes converting it to that radical form, or I'm sorry, the exponential form, makes it really easy to evaluate these things. So there's our solution there. So now on this one, we have a cubic, and we have a -8 in there. Now I know just from my extensive mathematic background, I guess, that 8 is 2 times 2 times 2. So to get a -8, those all had to be -2's. So I'm looking at the cube root of -2 cubed, a cubed, b to the 9th. Now I could go write them as fractions if I want to. I'm lazy, so I'm not going to. But I could. Okay? But I just like to think about it. I just need 3 of a kind to pull each of these out, right? So I have a -2 that's going to come out. Okay, I have 3 a's here, so I have an a that's going to come out. And I have 9 b's. So that means I have 3 sets of b's. So I'm going to have b, and I would have times b, or b cubed. this one gets a little wild, right? 256. Good gravy. Well, I don't know. I haven't broken this one down. I mean, I know that it's 4 just from my experience. But I'm going to try to approach it as a student. So I see that it's even, so I'm going to divide it by 2. Okay? So that's what I always did when I made these factor trees was if it's even, just divide that bad boy by 2. And I got 128. I'm going to do that same thing again. I got a 64. 64 is easier. I know that's 8 times 8. And these 8s are each an additional 3 2s. So let's look at what we have here. I have to figure out how many 2s I pulled out because that was all a bunch of 2s. Because I don't really need the parentheses. So I have 1, 2, 3, 4, 5, 6, 7, 8. So 256 is 2 to the 8th. And then I have x to the 12th, y to the 24th. So if I'm looking at a 4th root, I need 4 of a kind to take stuff out, right? And if I have 8 2's there, that means that I could pull out 2 2's. So I'm going to have 2 squared. X to the 12th, I could pull out 3 sets of 4. I'm going to have x cubed. And y to the 24th, I could pull out 6 sets of y's. Now the last thing here, with your number that's raised to an exponent, you have to clean that up. So 2 squared is 4. I think that's it, yeah. So that's how we simplify nth roots. Until next time, y'all.